consider the new method using upper bounds and lower bounds for the comparison. Objective. Even if the limit, this ratio does not exist, we can still compare two growth functions. We just, get around that limit way. All right, so how to do it? The function g of n is usually a simple function like n squared, and log n. It's natural, so why we use g of n usually a simple function? Because when we describe classes of growth functions, GL function, the one we use for the concise description, we want to use relatively simple functions as the basic comparison functions. Okay, the function f of n could be a complex function. All right, and then in this situation, how to find a reasonable way to measure f of n function, use some constant multiple of g of n to approximate f of n. F of n relatively complex, and the g of n very simple, but how do we represent a complex function in terms of a simple function? So that's the objective. So the way, use constant multiples of g of n. Specifically, we try to find two positive constants, C1 and C2, such that C2 multiple of g of n less than equal to f of n, and less than equal to C1 times g of n. So here you can see from this inequality, we can describe f of n function, relatively more complex growth function, using two bounds, C2 times g of n, that's the lower bound, and the C1 times g of n, the upper bound. So using upper bound and the lower bound, we can describe the range, approximate range for this f of n. How about that? Okay, that gives us an idea. All right, so you use f of n, so you have a growth function f of n, but when we compare it with the g of n, it is greater than C2 multiple, C2 constant coefficient, and the C1, it's less than C1 times g of n. We know C1, C2, they belong to the same category, right? Belong to the same set of functions. What set? Big theta of g of n, right? Using our asymptotic notation from the previous slide, big theta of g of n. Okay, so we get what we need we get what we need, right? Yeah. Here, we do not use the limit way, right? We use the inequality way. Inequality way helps us to get around that limit way. And we eventually, we can find the information that f of m belongs to big theta of g of m. Okay, yeah, all right. So this method works no matter the limit of those two functions exists or not. Even if it exists, this method also works. Yeah. Even if the limit exists, this method also works. Okay, yeah, yeah. But the good thing for this method, when the limit method does not work, we can still use this inequality way. Okay, yeah. But one comment, yeah. If the limit way works, most of the times, the limit way is better. Yeah. Why? Because we can use the L'Hopital's rule. If the limit exists, then we can use the limit calculation techniques. We have many techniques to calculate the limits. Yeah. And those techniques could be very powerful. So we want to take advantage of those powerful techniques to calculate the limits. Okay, yeah. So the limit way is pretty good. It has the advantage. Yeah. All right. Yeah. Yeah. All right.